Okay, we are here with Lynn to talk about expressions with exponents. Ready to go, Lynn?
Yep.
Okay, so we're going to talk about writing expressions, and then we're going to talk about evaluating those expressions, which means finding how much they are, what their value is. So let's start with writing expressions. Okay, so first, why do we use exponents? Well, the answer is it makes your math life easier, believe it or not. Okay, so let's get a look at an example. So here we have 3 times 3 times 3 times 3 times 3 times 3 times 3. It looks like there are 7 of those 3's. I'm tired just saying it, and if I were to write it out every time if I had that, gosh, that would be a pain, right?
Yeah.
Okay, so what's the easier way to write that with exponents, do you know?
3 to the 7th.
3 to the 7th power, right? So much easier to write it, right?
Mm-hmm.
Okay, great. So let's look at some other examples. Let's try out this one. What would this one be? See if you can figure that out.
I have to count.
Go ahead. Go ahead and count.
6 to the 8th.
6 to the 8th. Very good. Okay, how about this one right here?
18 to the 4th.
18 to the 4th, right? Okay, and then here's a little bit of a trickier one. What's tricky about this one?
The addition in it.
The addition, and here we say that the number at the bottom, like for instance, right here, the number 3, that's the base, and then the exponent is the 7. So what do we have down here? Do we have the same base or different bases?
Oh, different bases.
Okay, so can you just combine those with the same exponent or not?
No.
No, the bases have to be the same if you're going to have the exponent. Like you have 3 to the 7th up there. They all have to be 3's. You can't throw a 2 in there or a 19 in there and have it still be to the 7th, right? Okay, so what's this one down here going to be then?
It's going to be 2 to the 4th plus 3 to the 5th.
Very good. That's excellent. Okay, so now let's talk about finding out what the value of exponents is. So let's look at an example here. So when we say evaluating, that's just a fancy word for finding the value of something. And so 2 to the 4th, if you're going to write that out, multiplying it out without an exponent, how would you write that?
2 times 2 times 2 times 2.
Very good. So it's 2 times 2 times 2 times 2, which is a real pain. But what's the value of that? Can you figure that out? Do a little mental math?
It's 32.
Maybe. Let's see. 2 times 2 is?
4.
Times 2?
8.
Times 2 more?
64.
Close. Let's do it.
Oh my goodness. Okay.
That's all right. Let's go through it one step at a time. So 2 times 2 is?
4.
Times 2 more?
8.
Times the last 2. What's 8 times 2?
Oh, times 2? Oh, okay. It's 16.
Very good. So when we evaluate 2 to the 4th, that's just saying 2 to the, that's just the same as 16. Okay? All right. So now, how about this one? 3 to the 3rd plus 5.
Okay.
Okay, what do you think 3 to the 3rd might be? You can
9.
talk it out. So 3 to the 2nd is 9, right?
Oh, yeah, okay,
So 3 to the 3rd would be 9 times another 3 would be...
Sorry, say that one more time.
9 times 3?
9 times 3?
Yep.
Oh, I get it. Okay, 27.
Good. So let's go ahead and write this out to make it easier. So we have 3 times 3 is?
9.
Times another 3?
27.
And then plus 5?
Yep.
Would be 27 plus 5. Can you do a little
33.
mental math? Close. It's 32.
Oh my goodness. Okay.
Okay? So that's how you go ahead and evaluate exponents. Let's look at a special case now. What's 1 to the 3rd? If we write that out, it's 1 times 1 times 1. So what would that be?
1.
1, right? Seems pretty easy. How about this one? 1 to the 2,983rd power. What would that be?
1.
Yeah. And how did you do that without writing 1 2,983 times?
Because 1 times itself is 1.
Yeah, no matter how many times you put 1 times 1 times 1, it's just going to be 1, right?
Mm-hmm.
So let's go ahead and write a rule. See if this sounds right to you. 1 to any power is equal to 1. Does that sound right?
Mm-hmm. Oh, 1 to any power?
Yeah, you put any power up there whether it's 1 to the 3rd like we did or 1 to the 2,983rd.
Oh, yeah.
It's going to be 1, right?
Yeah.
Okay, so that's a good rule. How about, let's try another example here. 0 to the 4th. If we write that out, what would that be?
0 times 0 times 0 times 0 times 0.
Good. Okay, and what's that going to be?
0.
0, right? How about this one? 0 to the 427th power.
0.
0, okay. And how did you know that so quickly?
Because 0 times itself is 0.
Because 0 times anything is 0,
yeah.
right?
Yeah.
Right? Including times itself. So we can write another rule. 0 to any power is equal to 0. Does that sound right?
Mm-hmm.
Okay, good. And there's one other thing, though, that we want to point out, and that's why we put this asterisk there, and that is that except for 0 to the 0 power. That's a special case, but we'll talk about that later in a later in math, okay?
Okay.
All right, great job.